Not really sure.
Yeah, I don't know what really happened. She's like, "Oh, you guys should remember this," and I'm like, "I hope I do."
All right, there are three transformations of this of this here, and you kind of got them. It's right one. Well,
Oh,
your arrow's going in the wrong direction. So the inside one here is always opposite of what you think.
oh,
This two on the left here is a vertical stretch,
and that would be multiplying the
the y
y
value.
units by 2.
Yep. And then the last one here is up two. You got that on
And
the
that would
right.
be just like everything moves up by 2.
Yeah. Now, I don't know. I think on your test, they actually do want you to graph these transformations. If you're going to do one at a time, you actually need three graphs because there's three transformations. So they must be wanting to
Yeah.
like combine them.
Yeah, I realized that after I did that problem. I was like, "Oh, wait a second. I was supposed to show my work in a sense."
So you can actually do them all at once. One of the problems with your graph here is there's not like this looks more like an absolute value function than
Oh,
it needs to have some more sort of U shape to it.
and then how do is there any reason why it has a little bit more of a U shape? Or is it just like so you can
My guess is what your points are not quite correct. Um,
oh,
so let me show you how one way to do this, see if you like this. So xy from the parent function is -2, -1, 0, 1, and 2, 0, 1, 4, 1, 4. That's the parent function. That's for a parabola. So
oh,
let me graph that
that's
here.
like just the base of everything.
Yep. So let me graph that here. So you can see how this has more of a U shape to it.
Oh,
It's not very good. Um, that's a little bit better. Okay. So you alluded to this, and I think that's really the right way to do this once you've kind of seen this a few times, is like what affects the x? Does the right one affect the x?
yes, it does.
Does the vertical stretch affect the x?
Um, no, it does not.
Does the up two affect the x?
Yes. Wait, no.
No, it does not. So the right one affects the x only. So basically every x value is going right one. -1, 0, 1, 2, and 3. You're adding
0,
one
1, 3.
to each of the x values.
Oh, that's a pretty good way to do that, actually.
Okay. Well, you alluded to it, and that is the best way to do it, but it takes some maturity in your math. Now, the second one here is the vertical stretch by 2. That affects y. The up 2 affects y. And you probably remember me telling you this in algebra. It's like the order matters. The order matters, and like maybe you didn't know why. Well, now you know why. The order matters. You first multiply the y values by 2, and then add 2 to them for the up 2. So you take this
Oh,
4, multiply it by 2, that's 8. Add to it, that's 10.
and that's 10. All right, so
Take this 1, multiply it by 2, and then add 2.
then that would just be 4, correct?
Good. 0 multiplied by 2 is 0, plus 2 is 2.
Mm-hmm.
Same thing down here. Now there's symmetry, so if you don't get the same values, you've made a mistake here.
Yeah.
All right, so now we graph the new points here. -1, 10. Kind of hard to graph that one. I'll just kind of put that there. 0, 4. Okay. 1, 2, 2, 4, 3, 10. And notice it still has the same U shape roughly there.
Oh. So then
So your ability to graph really comes from how you handle the transformations. And one way to do it is to figure out what affects the x, what affects the y. You were going to say something. I apologize.
oh yeah. Oh, so in order to find all this, like a really solid way to do it is kind of have that X and Y like table looking thing. Just
Yes,
to
you have to know the parent
I
function for
guess
all of them.
shows your work as well and then just lets you see it.
Yes.
All right, all right.
Let me find another one that works kind of nicely. All right, let's do number 5 next.
I guess this is a little bit early for this question, but this kind of stuff, like I saw this last year in algebra, I'm pretty sure, correct?
Yeah, you see it again in algebra 2.
All right. And then with it being in geometry, is this gonna tie into like more, I
I have no
guess
idea. I have no idea why you're doing this. It'd be like going to a Spanish class and going back to learning, I don't know, English or something. It's like you're going backwards.
Okay. Yeah, I don't
I
know
don't know.
why.
I don't know.
She's like new unit, and I was like, all right, looks familiar, I guess.
All right. So the parent function here is the square root of x. And there are 1, 2, 3 transformations to this one. The first one is the -3. The second one is this 2 on the left. The third one is this 2 on the right.
Mhm.
So what's the first one? What does this x -3 do?
It's moving all the x units over by 3 to the right.
So right 3. Now, I've shown this before, and I really like this, but most people don't. Is like, what does it affect? And this one affects the x. And then we write the rule. The rule is x plus 3. Like you're going to add 3 to the x value. And we said that verbally last time. So the second one is this 2 on the outside. That's a vertical stretch by 2. It affects the y value. And you take your y value and you multiply it by 2. Or somehow you indicate like times 2. The last one here, maybe do it without the variable. The last one here is the +2 on the outside. So that's up 2, and that only affects the y, and then you add 2 to the y.
All right.
So
and I have a question. I'm treating that square root like it's parentheses almost, correct?
Yes, exactly.
Okay, cool.
There's implied parentheses. Now you have to know your parent function of your square root. And this is one of those things where if you haven't done it in a while, you will not remember. But you have to be able to take the square root, so it's got to be nice numbers. Square root of 0 is 0. Square root of 1 is 1.
2, 3, 4.
Right. So now our new x and new y, we have the rule. Every x value is going to go +3. So 3, 4, 7, 12, 19. Just adding 3.
And that's to the x units, correct?
Yes. Only so the ones that affect x, you only affect x, y, same thing. So for first, vertical stretch by 2 means you're multiplying the y values by 2, and then you're adding 2 to them. Will you will you attempt to give me the new y values?
So the y values are multiplying by 2 now, correct?
That's the first thing, and then they're added by 2 for the second.
Oh, so then I'm looking at it as 2 times 0, 0 plus 2 equals 2.
Yes.
And then 4 times 2 is 8, plus 2 is 10. 7 times 2 is 4.
This one right here. This one.
Oh my gosh, my bad. Sorry.
Yeah.
1 times 2 is 2, plus 2 is 4.
Good.
And then 2 times 2 is 4, plus 2 is 6.
Good.
And then, I mean, would it also just become 8 and 10 for the others just because it's going up by 2?
Yes.
All right.
That's sort of interesting in its own right, but yeah. Good. So we graph the original just to kind of see if we're on the right track here. Notice you can't really graph more than 3 points. So that's, I mean, that's kind of annoying, but that's the way it is.
Uh-huh.
The new one here is 3, 2. So there's 3, 2, 4, 4. I think we can get one more in. 7, 6. Like that.
And
Okay.
then, so not all the graphs need to have kind of like that U or V shape to it.
Well, the square root function has this unique
Kind of like line going
yeah.
on.
So there's all these parent functions that you may need to know. Let me see if I can find an image of that. All right, so you know some of these. Let me snip this in. So there's some expectation here that you know some of these graphs, like a line, absolute value, quadratic, square root, cubic,
Uh-huh.
cube root. Maybe you don't know the last one yet. I don't know. I don't think you've seen that yet. But there's like some expectation that you know this. And we're adding in that now you need to know the parent function for each of these, meaning the table, this table of values. So like what I remember and I thought it was algebra 2, the last like test was they gave you a function, you had to do all the transformations, you had to graph it. Does your teacher also teach algebra 2 by chance?
Um, no,
Okay.
thankfully.
Okay.
I hope.
Right. All
I've
right.
already been stuck with her for 2 years, so I've had enough of her.
All right. Do you already have your teacher assignment for next year?
Um, no, I don't think I find out until the summer, unfortunately.
Okay. Well, there's a chance you can get 3 in a row. So,
At that point, I just went off 4 years because I'd be so used to her.
all right, here we go. Let's look at number 7. Do you have a question?
Um, no, I don't think so.
All right. I am so tired of the same transformations here. I'm going to change this up here.
All
Let's
right, yeah, I
go.
was gonna say just because like parent and parent and parents just kind of.
Let's go -3 and let's make this the 2 is fine, but I'd like to
Let's make it 4. Let's mess with it.
in front. Okay. The numbers are gonna get kind of large here to the point where you're not going to see it, but that's okay.
Oh, all
This
right.
the parent function here is a cubic. Okay. And so for a cubic, you need the following points. You need -2, -1, 0, 1, and 2. Okay. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. -1 cubed is -1, -2 cubed is -8. So notice there is a bit of symmetry here. It's not the same though as the others. Like
Oh,
one,
sorry. Could you say that again? I just like.
there's kind
Oh,
of a bit of symmetry that you got -8 and 8, 1 and
oh
-1,
yeah, one and
kind
one,
of,
-1. Yeah, a little
yeah.
bit.
Okay. So this one has 3 transformations again. Can you give me any of those transformations, please?
It will be moving 1 to the right.
Okay.
It will be moving 3 units down, and it will be vertically stretched by 4.
Okay. Now the order again matters. Like down 3 comes at the end.
Oh,
Really important. Like in the order is based on how you evaluate it. So if you were to put a number in for X, you'd first subtract 1. That's why it's right 1. You'd cube it. Nothing changes with that. Then you'd multiply it by 4. That's why the vertical stretch by 4 is next. Then you would subtract 3. That's why down 3 is last.
uh-huh. Okay, I'll have to keep that in mind. Parentheses left, far right.
Yeah. Okay. So new X, new Y. All right. You just said it here. The X is going to go right 1. So all of these X values are going to go right 1. You're adding 1. The -1, 0, 1, 2, and 3. Your Y, you're first multiplying by 4, and then you're subtracting 3. So it might be good to, say, okay, multiply by 4, then subtract 3.
Multiply by 4, subtract by 3. So then, and I'm looking at the y units for this,
Just the
correct?
y, just the y now. Yep. You don't really care about the x anymore.
Right. That's why the order matters, because then you
Yes.
can just do it like that. All right. Yeah, I forgot about that. If you multiply by that by 4, that's negative 32 minus 3, negative 35.
That's right.
And then for negative 1, that would just be negative 4 minus 3, negative 7.
Okay.
And then 0 would just be negative 3.
Good.
And then I'm pretty sure this isn't like the effective way to do it, but could I just say positive 7 and positive 35?
So is it so times 4? 1 times 4 is 4, minus 3 though is 1.
Okay, then never mind. I will not be doing
So it
that.
kind of has the symmetry, kind of. And here's what it is. Well, what it is the displacement kind of becomes the same. But don't focus too much on that.
Yeah,
And that
just do it, like do the extra like 2 steps so you
yeah,
just don't
yeah.
make
I mean, there's some
mistakes.
of that you can take advantage of, but not in this problem. So our what does our original graph look like? You've got this 1, 1, 2, 8, which can't even get on here. Negative 1, 1. So it's this kind of this snake shape.
Oh,
Okay. So this
so when
other
it for a question just for drawing that one, so it kind of goes, those 3 dots are in a row like that. Do I just make it kind of go straight down again?
kind of, I mean, there should be some curvature to it.
Oh,
It's
all
not
right.
really
Because
fair to you to
I don't
graph
want
it.
like some shape where it's like straight line, straight line, straight line, sort of.
It's hard because the graph isn't big enough to give you the
Give you the true scale for all
yeah,
of it.
yeah. And it's worse here. So we got negative 1, negative 35, I can't graph, but 0 minus 7 I can, 1 minus 3 I can, 2, 1 I can. Okay, so that's kind of that straight line that you're asking about.
Oh,
It's not really though. So what it is it really kind of comes down like that. There's kind of that curvature, and then it goes the other way. It curves down like that.
oh,
But this is not a good example. I mean, it's kind of a wonky thing. But I mean, what I sense that you're understanding is how to get the new x and y pairs from the graph here. And now we can go and do some of the more difficult ones with worse transformations.
all right. Yeah, sounds good to me.
All right, so I'd like to do 4 next. All right, so 4 says 4's f of x is minus 1/2 x plus 3 squared minus 4. This has 1, 2, 3, 4 transformations.
Uh,
Just if you want to, and this one is different than what you think, the one inside. It's always kind of
um,
opposite.
it's so it wouldn't. I mean, naturally, I'd say it moves to the left by 3,
Yes, left 3.
and then second step, I would say. Mm, honestly, I'd say reflect over to the x-axis,
Okay.
and then I would say stretch, no, shrink by I guess 2.
So that's the correct wording that I use because it is by a factor of 2. Some teachers allow, I'm sorry, some teachers allow you to say by 1/2.
Oh,
You are effectively multiplying the y value by 1/2. You can also think of it as dividing by 2.
oh.
The correct one is to say it's shrunk by a factor of 1, a factor of 2,
All right, I'll
which
just
me.
make sure to keep doing that and play it safe. And the fourth part would be just move down 4 units
Very good.
vertically.
Very good. Okay. All right. So let me give you the parent function from before. XY here. and it becomes 4, 1, 0, 1, 4.
41014.
So all right,
And
so which
then
which of these affect the x?
wait, sorry, I've got a quick question just for that one.
Sure.
Um, how do you know it's like 41014 instead of just like 1 and like
Because
two
the
and two?
parent the I'm sorry, I didn't even address this. The parent function is x squared. I'm putting this number in for x.
So I'm just so you're just multiplying -2 times -2, which gives you +4. -1
Yes.
times -1 +1. Okay, all right,
Yes.
that's
Yes.
easy.
Good.
And that's just how you'd figure out all of these.
Yeah, I mean they're worth memorizing, but when I say memorize, I mean you can quickly once you memorize it, you realize, oh, that's how I do it. You like you just said, you just
Yeah,
multiply.
like it's just common sense
Yes,
too.
yes. So
All
the
right, so
so
then
in the transformed one, I'm asking you here out of 1, 2, 3, and 4, which of these affect the x? Which of these affect the y?
left by 3 affects the x,
Does anything else affect the x?
and shrunk by 2.
That affects y.
Um, wait, sorry, I'm just trying to visualize that in my head real quick. Shrunk by 2.
So
Okay, yeah, that
it,
does
it, it
affect.
means it was here and it goes down.
I mean, I guess then it would have to be down. No.
So okay, I'm just trying to get you to think here. These affect y. This affects x.
Oh, okay. Sorry. I thought there was like another one, and I was like,
No,
no, I think L affects Y.
yeah. I want you to be confident enough to say, nope. That's it. I've done it. I've got it.
All right. Well, I will definitely know that for sure now as well. Um. Okay, so I have a question with this reflective
Yep.
or x-axis.
Yep.
Am I just gonna say like negative?
It it
Like
it,
just.
cha- it it changes the y. It changes the sign of y.
Mhm. So should I do that part last?
No, it's done in this order.
So would I write -2, -4, -1, -1, 0, 0?
No, we wanted to go left 3 first. That's -5, -4, -3, -2, -1. Maybe you said that. I'm sorry.
Um,
We want to go
I
left 3
think I said
first.
something similar.
Okay. For y, this is where it gets complicated. You first negate it, and
Mhm.
you divide it by 2, then you go down by 4.
So then I would look at 4 as -4 divided by 2, -2, and then move it down
Down.
by 4, -6.
Yes. Okay. Now, what is the problem with 1 when you do
Um,
an actual problem?
it will -1 shrunk by negative. It's gonna be the same number as the other.
Well, it's going to be a fraction. It's going to be -1 divided by 2 -4. And I don't know how you feel about that.
-1 divided by 2 -4. I mean, I just so what I look at that as like -1/2 -4 then becomes like -2.
Nope. I mean, it becomes -9/2. Okay. But like what I was hoping you'd say is like you don't really like that. You don't really want to deal with fractions.
Uh,
Okay. And I want you to think, well, why is it a fraction? Well, it's because four was divisible by 2 or -4, but 1 is not. What's the difference between 1 and 4? Kind of a glue.
um, 4 can be like divided and stuff like that, and like change the numbers if it's put in with others. But if one like multiplication or division wise, it'll just stay as one.
Yeah, four is even, so it's divisible by 2, but 1 is not. Now you probably noticed I left some room up here.
Hmm. I did
So,
notice that.
so what happens when you square -3? What does that become?
+9.
Is that any better than 1 when you divide it by 2?
Definitely.
Well, it's still a fraction, right?
All
Do you
right,
see that?
guess. Or I mean, it could be looked at more as a whole number.
9 divided by 2. 9 divided. See, that's still a fraction.
Yeah.
All right. I know I'm losing you here. If
Sorry,
you go,
I'm just like my
if you go,
brain is just like trying to
yeah.
visualize it.
Well, and I was trying to get you to see is because if we go a little bit further, we go to -4, you get to 16. All of a sudden, that's not too bad because you can
Oh,
divide it by 2 because it's even.
so would I also multiply the -4 by 2 or no?
No, no, no. What I'm trying to show you is that you don't necessarily always pick the parent function. Like sometimes you go grab other values because they're nicer.
Oh,
Like the thought for me, the thought of taking 1/2 and subtracting 4 -9/2 and having to graph it. I mean, I don't find that very appealing because it's not a nice point on the graph.
uh-huh.
Like maybe you don't care. You're like, well, it's between -4 -5. And I'm like, you're right. But 16, if I negate it, -16 divided by 2 is -8, down 4 is -12. Like I
Uh-huh.
think that's nice. I mean, that's a nice point for me.
Yeah, it's like a very easy one.
Right. But you have to be comfortable with this idea that you might have to go outside of your circle, like whatever you feel like is reasonable.
Uh-huh.
And I don't know if I'm hearing, well, I know you're tired, but but I'm also kind of hearing like ambivalence about this, and it really would help. But if you don't like that, we can just stick to the -4 minus or -1/2 -4.
So I'm looking at it. So like with 16 and 4, so I would shrink it by 2. So then that would be 8, and then down by 4 is 4.
You have to reflect it though. You got to reflect it still.
Oh, right. -16 shrunk by 2, -8 down 4, -12. Wait.
Yes.
Okay, so -12 is the correct one for that.
And -4 left 3 is -7. And what I'm suggesting is like this is a nice point, and this is a nice point, but we're not going to use -4 because
Uh, it's just like, has that uncommon number. So then my question is, so 4.5 is 9 and 2. Or 9 divided by 2.
yes.
So I would mark 4.5 on the graph, but with those,
Um,
I'd mark like 4 and -4.5 or 4.5. But then with these, I would mark -5, -6 because they're just different, like, just totally different numbers. So
yeah,
it's like not.
it's like, do you want to be here or do you want to be, in between? And
Uh-huh.
for this one, it probably doesn't matter that much, but it will matter on some of the more difficult ones, like number 2 has a -3/4. I'm sorry, number 3 on your problem set has a -3/4 in front. That's where it really does matter. You want nice points.
Uh-huh.
So I'm not sure I've convinced you, but I mean, we can
I
keep
mean,
going.
I definitely see the benefits to it. I just need to like remember that
Yeah.
formula and stuff and just
All
get that
right.
in my head
So
because
let's
I see
let's
how
go.
that makes it easier.
So let's go to this 0 here. 0 negated 0 doesn't change anything. Shrunk by 2 divided by 2. 0 divided by 2 is still 0. Down 4 is -4.
Hmm.
We're gonna skip. We're gonna skip -2. So the 2 went to the -1. 4. You reflect it over the x-axis, negate it, divide by 2, and then down 4. What does that become?
If you reflect over -4 shrunk by 2 -2 -6.
Okay, and notice the nice symmetry there with this other point.
Uh-huh.
So,
I have a question about now.
yep.
So how do you pick which number? Like, could you just hypothetically just pick like any numbers you want that you can think are nice numbers and just kind of have like a crazy graph and it would just be right?
Well, you have some idea of what's nice based on this over here.
Uh-huh.
So like so what I'm trying to say is that this number on the outside, this -1/2, while it doesn't impact the x, it actually does impact the x. Like we say vertical stretch, but it really says pick numbers that are multiples of 2. So yeah,
Uh-huh.
-2 is a multiple of 2, -4 is a multiple of 2, 0 and 2 are multiples of 2.
Okay. I don't know why this is just like not registering super well with me.
Well, I can tell you from experience, the reason is because you're used to just doing this standard set and you're just okay with this fractions.
Uh,
And maybe your teacher is okay with that too.
yeah, but I don't want to just like, do the minimum, like I want to
Yeah,
be able to be ready for the future of my
right,
mathematical career, I guess you could
right.
say. So
Well, absolutely. And that's why I'm showing you this. Like sometimes we get stuck saying, oh, I can only use these numbers, and really you don't
you
want
can
to.
kind of use whatever.
Yes. So they're not random. They're chosen based
Calculate.
on, yeah, they're calculated based on what works out nicely.
Huh. Okay. I guess, because if you look at it, then if you pick a different number, all right, I get so do you still need to have like
Yes. Typically they
five
want
things?
five
Like
for
is that like is like five always just like the given sort of?
the quadratic requires 3 points for uniqueness. So a line requires 2 points. You have to have
Uh-huh.
two unique points. Quadratic actually only requires 3 points, but the teachers, they want five. Yeah, I don't, that's just what they want. For the
Uh-huh.
line, they typically want, I don't know, more than two, I'll say.
Yeah.
But you actually only need two by definition. Same with the quadratic, you only need three.
Okay. But obviously I need to write five in order to get a good grade.
Yes.
Huh. Okay. Do you have just curious, do you know why they chose five? Just so it's like more work for the kid to do for practice or
I think because it gives you the shape a little bit nicer. Like if I give you 3 points here, you could give me a lot of these things.
uh-huh.
And it's because you can't, as a human,
You just can't really tell.
yeah, but there's a way, if you were as a computer, you can create what's called the spline, SPLINE, which is the curve that connects the points, which is why you only need the three because that gives you enough information to get it.
Uh-huh.
The spline is what connects the 2 points, the curve that goes between them.
Okay. I guess you learn something new every day, and that's kind of interesting. With
Yeah.
the just being able to use, because I guess that makes sense too if you think about it. With 3 points, because I guess that's giving you the like bottom or top of the graph, and then 2 points on where it's kind of like leading off to.
Yeah.
And I guess that makes sense as well for why you need five because I mean you could the lines could kind of go any direction after hitting those 2 points.
So the reason you need 3 points is because there are three unknowns in the quadratic equation, and those 3 points, if they are unique, will allow you to solve for it. It doesn't have to be the vertex and 2 points on either side. It can just be two. It can be 3 points anywhere.
Oh. So then, yeah, I guess that makes sense. AX squared BX C.
Like you ever wonder how like we can slingshot around something? And we
Like
don't
if
we
you're running and you like grab a pole or something, you kind of like swing
sure,
around it.
yeah, I was thinking space travel, but it's kind of the same idea. Like you
Oh,
don't
yeah,
you
yeah, a lot more
you don't
advanced than
you
what I
don't
was
have
thinking.
this data point. You have these data points,
Uh-huh.
and you can still predict that. It's because we know the type of motion that's described. We know the laws that govern this.
And
It's
then those
it's
laws would be like the formula in this sense, correct?
yes, and that so it's nice to have the vertex, but it's not necessary. You just need three unique points.
Three unique points.
Look up global. If you're interested, look up GPS, like how it's actually done. Maybe there's a kind of a high school level explanation of it. There should be. It's kind of the same
Hopefully.
deal. It actually doesn't need as much data as you'd think for it to work. It's kind of amazing.
Really? So is it so it's not huh. I guess so like what I guess I thought GPS would be like is like it connects to like a satellite or something on just like where you are and then it tries to base
Well,
it off that or something.
well,
But
there's a satellite, there's you, and there's probably a tower.
uh
And that's how I believe that's how it's done.
And that's a 45, 45, 90.
No,
Triangle.
it's a triangle. So that's how it's done. But take a look at that, and you'll be amazed at how much we can get from just a small piece of information, a couple
Huh.
of data
So would
points.
like sonar work like that for like submarines or boats or whatever
It,
as well?
I believe sonar works more in terms of like, it's like it's calculating time there and back. Again, I'm not an expert at this, but there's plenty of videos and things out there. We do
No
have to
more
stop
than
here. We do have to stop here though, Zach. But I appreciate the questions.